here's the graph of y equals cos theta. We're in degrees here along the x-axis, and we've labelled that theta for the angle, and the y-axis here are the outputs of this function. Now the maximum value in the output is 1 and the minimum value is -1. You can't get anything out for any value of theta. You can't get anything else out. Its maximum value is 1, its minimum value is -1. Anything in between is okay. This graph is a periodic graph, so it has a period, and that means it repeats. The pattern repeats, the shape repeats, and in this case it's every 360 degrees. This shape here is then repeated. You can see it over here too, there, and so on. So it has a period of 360 degrees. This graph is symmetrical about the y-axis. We call this an even function. There's some good results here. First of all, we've got the idea that cos of theta plus 360 degrees is the same value as cos of theta. You get the same value of y for each of these because of this period of 360 degrees. The second thing, because of this line of symmetry here on the y-axis, we get this result, that cos of theta is exactly the same value as cos of minus theta. This also means that the graph is even because of this symmetry about the y-axis. Let's have a look at a few examples of how to solve equations. So quite often we're given a range of values for the angle that we're trying to find a solution to. Cos theta equals √3/2, and we're going to find all the values of theta in this range, 0 to 360 degrees. So on the graph, that's from here, 0 to 360 degrees. We grab our calculator and we're going to do the inverse cos of √3/2. And we're in degrees mode, and it's telling us that that's 30 degrees. So the value of theta is 30 degrees. Let's have a look at that on the graph. So here's 180, there's 90, so 30 is probably about there. This is just a sketch. So if I draw a line up to the curve and then along here, that value there is √3/2. Now if I extend this line here, we can see that within the range 0 to 360, there's another solution for √3/2, and it's here. So I'm just going to draw a line down there, and what we're trying to do is find the value of the degrees here. Well, because of the symmetry of this graph, this here from 0 to 30 is 30 degrees, and this here from 360 to our unknown value is also 30 degrees. So to find a second solution, I can do 360 minus 30, which gives me 330 degrees, and that is also a value for theta. We can check these on a calculator as well. If I turn it on, and if I go cos of 30, I should get √3/2, which I do. And similarly, if I go cos of 330, I should get the same value, which I do. Let's do one more. We'll look at cos of theta equals minus √3/2. Same process initially, so we do the inverse cos of minus √3/2, and it's telling us that it's 150 degrees. So theta equals 150 degrees. Where's that on the graph? Well, there's 180, So, and there's 90, so it's much closer to this one this time. Let's mark it there. And we're going down here, and similarly, if we go across there, that value there on the y-axis is our minus root 3 over 2. And if we just draw another horizontal line, we can see that here between 0 and 360 degrees, there's another solution right there. So this one is our 150 degrees, and we're trying to find the value of this one. Again, because of the symmetry of the graph, from 0 to 150 is the same as from 360 to our value. So there is 150 degrees. So again, just like we did here, we can do 360 minus our first value. And 360 minus 150 is 210 degrees. Let's grab the calculator to check it. So we do cos of 150. We get minus root 3 over 2, brilliant. And if we do cos of 210, we get minus root 3 over 2. So the key thing to remember is to find other solutions for cos. We do 360 degrees minus the first solution that we get.